Hey there, this is Jenny Chen. I'm the founder of 3D Heals. Welcome to the Lattice podcast, the official podcast for 3D Heals. This is where you will find fun but in-depth conversations with technological game changers, creative minds, entrepreneurs, rule breakers, and more, focusing on how we can use 3D technologies like 3D printing and bioprinting to reinvent healthcare and even life sciences. This podcast will also include AMA or Ask Me Anything sessions, past Instagram live interviews with influencers, and other direct engagements with our tribe. Well, thank you very much for joining me for this Instagram live. This is supposed to be like casual, semi-casual kind of conversation just to have fun. I really love at least our Instagram followers. I think they're extremely creative and curious and fun. So I thought that we should have some conversations to, serve the purpose of, letting people know what you're doing, what these experts are doing, and some tips and guides for people. But let's first introduce you. So Fabio, you're a jack of all trades, basically. I was looking at your bio and then you're like everything, and I believe it because I experienced it when I asked you questions that you can answer all of them, either from CAD/CAM to metal 3D printing to Brazil ecosystem. But why don't you give us, a more thorough explanation of what all those titles mean? What do you do with Farco Technologies, for example, and then
Yeah. I do work with manufacturing since 91 when I left the technical school. I had been working with machining. I started working with machining and with CAD/CAM systems because of the machining. And because of that, also, I started to work in a company that was to sell machines. That's why I got in the medical industry. To machine implants. And then after some time, we were working with many kind of machining strategies and machining equipment for these industries. And one day, one customer came to me with a implant, a hip implant that was made by additive manufacturing. And I at that time, I had no idea how that part was made. And then because of that, I started to research in the area. And then I finally, actually, it's a kind of funny story. I went to one of supplier in Switzerland, and this supplier, I showed the part to the supplier and they said, okay, we cannot do that by machining. But I do have a customer that put parts like this for final precision work after some initial process that I don't know. Actually, it is inside a dark room, hidden inside the company because it was a very secret at that time. That was 2013. And then I said, okay, cool. Do you think that they can even talk to me? Then he said, oh, I don't know, but I'm sending some technician to fix the machine there. Do you want to go together with them? I said, okay, I try. And then I went to them, and after that, it was, I did visit the company. I saw the company, and the people there had been very nice to me. They showed how they do that implants. And that's why I started in this business. I did find the machine who do the work. And then I sold my first machine on the additive manufacturing world to a Brazilian company. And from there, I'm mixing, actually, the both things are very connected because you need to do all the precision work on the additive manufacturing implants anyway. So machining and additive manufacturing go very well together. Mm-hmm. And we're still doing both. We have a division for additive manufacturing machine. We have a division for machining.
Yeah.
Then because of that, we started to learn to get more knowledge, trainings, and things like that. And actually, because of the customers, we finally went to the standards making, something that I really like because it's a very good way to absorb technology, absorb new uh, information, and that's where when a normal Latin American guy would go sit in the same table with Striker people, with Airbus people, with Boeing people, and say, I disagree. So it's something that's it's very good for me as a person, and also it's a very good way to absorb new technology.
Well, where you are definitely is because you're a very adventurous person. I mean, it takes someone different to venture out to sit on the table with these different people. But now we're talking about, you mentioned a couple of things about machining and implants, and I will post a link. I think we already did, that you wrote an article for us recently about materials for metal 3D printing implants. Obviously, the airplane cars are different from implants. But can you point to us, what are some of the crucial difference when considering manufacturing an implant from the other things?
Yeah, additive manufacturing it's very broad subject. So we have even if you go to the standards, you have seven different process that's called additive manufacturing. So you have uh, photopolymerization that starts from resins. You have binder jetting that you glue powder and then you cook it in a clean and many things like that. So the first thing that very have a high impact in the implant market or implant making industry, it's the material itself. Mm-hmm. You need all the material are very controlled. So if you have a implant that's made by titanium, you need a very specific alloy. The chemistry of this alloy, it's very controlled. Not only because of the material properties or mechanical properties, but also because the biocompatibility itself. So when you go into implant making, the only technology that can do the things that go inside body right now for metals, it's powder bed fusion. Powder bed fusion, it's the technology that you make a very thin layer of powder and then you melt the contour to make the contour you need. Then you move that layer down and then you melt a new layer, and it's the only way that you can control the chemistry of the material that you are melting. Also, it's important for the medical industry. The content of this, so it's important that you know exactly what is having inside. Laser and electron beam powder bed fusion, both of them you can know what you're doing. You can vacuum for electron beam vacuum. It happens in vacuum. Laser you have a shielding gas to separate the process from the regular air. So both of them, you control what you put in your implants. Implants are very regulated on this. Also, more you know about your material, better you understand the final result. Since we are talking about metallurgy, you need to know what happens in the process because the process changes the material. For example, when you do machining, if you do a hip implant by machining, exactly the same material that starts the process ends the process because you are only removing material around the geometry you need for the final implant. When you're talking about additive manufacturing, powder bed fusion, you're talking about metallurgic that transforms the material by making it liquid, then solid again. So you need to know that will be difference on the microstructure of the material. You're gonna have difference on the you're gonna insert porosity or less or more porosity, and then it will change the performance of the material. Like if you have too many oxygen in the material, you reduce the fatigue that material can handle, so will last time before breaking. And so you need to have a very strict control of this thing. So what induces oxygen in the implant? It's how you handle your powder. So you need to control how storage, how you reuse, how you recycle the
Mm-hmm.
stock you use in the component.
So I have to admit, I've never used metal 3D printer. You know, all I have is extrusion FDM printer, or occasionally I get access to resin-based SLA. So I really don't know how you get in touch with the powder. I mean, I want to start from the beginning. Is when you talk about the feedstock, is where you get these powder. Do you have any favorite suppliers, or how do you know the correct feedstock for you?
Actually, most of the machine supplier, they do have partners, so they do deliver the theme or the recipe of the process already controlled for the process. Like if you talk to GE additive machines, they do have a powder maker inside the group, APNC in Canada. So they do supply the powder. They can supply the powder. The machines can work with other powders, but then you might have to develop a little bit the recipe for that specific powder.
I see.
You are not attached to that, but makes things easier. Also, other companies like SLM, like EOS, and everybody, they do have recipes to the powder that they have partnership. So that makes it a little bit easier when you work with titanium alloys.
That makes sense. It's almost like the filaments works best for certain they manufacture their own filaments and they work the best. So they kind of already
Yeah,
optimize the material.
like strategies, they do
Yes.
supply the filament, like Farm Labs, they do supply the resin.
Yeah.
In case of the metal machines, uh, most of them don't oblige you to use the material feedstock, but if it's easy, if it's working, and if it's not more expensive, why not?
Yeah. That makes sense. Um, all right. Well, I have another question, but before I go to my next question, I know we have some audiences, so feel free to ask questions. This is our, I would say, early Instagram live, and I look forward to engage everybody who are online as much as possible. So feel free, if you have any questions, just type in the comment area, I believe. I hope. All right, let's go to our next question. A couple months ago, I think we saw a very interesting conversation online. There's almost like, um, I don't know, a wrestle match between EBM and laser sensor technology. Where did that come from? And it seems like there is a trend moving towards laser. You want to explain us, like, what are the, maybe simple terms, what are the fundamental differences between these two technologies and why one is better versus the other for different applications, I assume, right?
When you said that's a trend, that's actually, it's more related to what's being made. Like because of the characteristics of each process, they are better for application, like everything in additive manufacturing. Additive manufacturing, you need to see the things in formal Wallace way. So it's not only the process itself, even for polymers. You need to check what you need after, what kind of heat treatments or metals you need heat treatments, or what kind of post-processing you need, because it's hard to remove remove the supports. We are not talking about polymers where you just cut with you break or only you cut with pliers. Actually, it's much more resistant in some ways. Then you have the machining, the precision, and things like that.
Hold on, my light
So,
just went off. Automatic light. Sorry.
no problem. We are seeing you very well. But anyway, when you talk about the metal and implants, actually depends what's trending. And depends of markets. Like United States, there had been a lot of talking about spinal cages and the smaller implants. And then you have the first wave of the additive manufacturing in implants. It's much more on joints, on hip joints and knees and things like that. But to understand this, you need to understand the differences in between the process. The main difference is the energy source.
Right.
Lasers are photons and electrons are electrons. So electron beam machine, you are speeding electrons over the material, and laser, you are speeding light over the material. So this is very different. They perform very different. You can have different amounts of energy. Like a regular laser machines normally work in something like 500 watts. Electron beam machines have 3,000 watts. So you can melt much more powder and bigger powder with all that energy with the electrons. But in laser, you need a much smaller powder. So this smaller powder is more delicate. So you need a smaller beam, and then you have more precision. Mm-hmm. So when we can say on overall that electron beam, it's much more productive. Electron beam melts better, or you can have better mechanical characteristics directly from the machine, and the laser, you have more precision. So if you are doing something that's really high precision, something that's maybe like a very small facial plate, a very small one, laser will be a better solution because you need more detail. Mm-hmm. But if you're doing a bigger part, or bulky parts like a joint, a hip joint, or a knee joint, then you make many, like 2,000-3,000 a year. Like if you get the biggest maker of hip joints in Europe, Lima Corporate, they make thousands. They have 150,000 hip implants made since 5 years ago. So they need productivity. They do need something that they wouldn't work with laser. They would use laser on smaller productions. Actually, they only use electron beam anyway. But that's something that you need to realize what is the best for each process. Actually, it's kind of common sense in the market that's for joints and bigger implants, you use electron beam, and that for very small ones, you do laser. But actually, you can do both. Mm-hmm. We have customers that use electron beam for facial implants, for cranial plates, and there is people in laser that do hip joints. So actually, you need to balance exactly what you need to choose what is the best technology for. So
yeah, and I'm also assuming that the limitation that you pointed out about either technology, that I'm assuming these the new machines are coming out right with better resolution and maybe higher productivity. Is that possible?
Yes, like SLM Solutions and EOS, both of them announced laser machines, with one with 10 lasers and the other one with 12 lasers to overcome the lack of speed. And then Arkham just may have a new machine, Spectra L, that have a make bigger parts for aerospace industry. So everything is evolving.
Yeah.
you need to evaluate your always application is key on this. You need
Oh,
to
speaking of
know what
which, Fabio,
application.
we got one question. Our first question of the day.
Sure.
What's the market of the current anatomical model? I don't know. That's
The
not really a
anatomical
metal thing.
model.
Yeah, I don't think people use metal.
That's a good question for Jenny.
Yeah, I think yeah, we wrote quite a bit about anatomical model space, and it's mostly polymer. They don't use metal. That's number one. Number two is it's mostly a hospital-based practice because hospital has bigger budget. And doing 3D printing right now is not really reimbursed, so it's still a pretty expensive activity. You either do it as a hobby or you do it seriously, and you actually invest serious money. So in the hospital, I would say the major organ systems would be heart, because congenital heart disease is a is a very high risk surgery, and people want to make sure that they know what they're facing as much as possible before going into this high risk procedure. I've seen a lot of applications in craniofacial maxillary reconstruction. As you know, it's pretty important how precision is very important. So, and I mean, basically every single organ system, if you have a difficult case, a tumor somewhere on the kidney or liver, people use it. So anatomical model, I would say of all organs, but high risk, the higher the risk, the surgery, the more application there are. So congenital heart disease is one thing that comes in mind right away, because the babies are so small and so precious, and you want to be as safe as possible. So that's my answer. What about you, Fabio? Do you have anything to add?
Yeah, I can add that for Brazilian market, most of the patient-specific implants have together anatomical models to check the fitting and also to guide the surgeon during the implantation.
Mm-hmm.
And even if you use off-the-shelf implant, but you have a very critical surgery, difficult surgeries and things like that.
That makes sense.
For the regular, I forgot the English name for. They are not using for, okay, you request an MRI or you request a CT scan, and the surgeon normally don't request a model to check the diagnostics, not for diagnostics, only for surgery preparation and to the patient specific inputs.
Yeah, so we don't really use those models as diagnostics as well, but FDA decided that anatomical model is considered a diagnostic tool. That's just how FDA is looking at that category of products. So when they regulate it, they use a certain guidelines regarding those anatomical models. They're considered diagnostic tool, actually. So it's just a nomenclature, I guess, and it does matter when it comes to regulation. But we use the same way. There's no difference. You use it for pre-surgical planning. Anyways, I have a slew of questions for you, but I don't want to spend a whole hour. It won't be a fun conversation anymore. But Fabio, have you bought any new gadgets or new hobby lately?
Where hobby things?
Yeah.
I bought not hobby things. I bought a light to be able to, because I have been doing many lectures and speeches. So what I bought is a new light. The light you can see.
I can see the light in your glasses.
So I don't know how to use it yet.
I get that? We wear glasses that reflect.
Yeah, I don't know how to use perfectly yet. Also, I had been doing a lot of. I have a class about standards and additive manufacturing next Monday for the first additive manufacturing training for the Brazilian hub of additive manufacturing.
Mm-hmm.
Gadgets. I am not. Actually, I am an old dog, Jen. I told you. Don't go back. Actually, I learned a lot about these new things on the computers and gadgets and things. I am a very old CAD/CAM guy. my first CAD-CAM had two different monitors for graphics and text. So you see the text in one monitor and the graphics in the other
Wow.
monitor in 1990. So I am not very of a gadget guy. I do what I bought recently. I bought new cell phones.
Nice.
I have a Motorola G series that I like. It's not the trend. I know that the trends are Samsung 12s and iPhone 12s, or Samsung 20s and iPhone 12s. I don't have any of that. The thing I like to buy coffee makers.
Okay.
Because I really like coffee, so I don't buy many gadgets or things like that. I should buy a new 3D printer.
I got
Office
one. I got a new 3D
I
printer.
should buy one because I have a resin and I have regular FDM ones, but both of them I have more than 3 years. So I should buy a new FDM one with a self platform leveling and sensors for the
Are you just leaving
filaments.
your Christmas wish list right now to me?
Maybe if you want to send, just send me. Go to
Well,
Alibaba.
I can print them. I'll print your coffee maker. How about that?
Yeah.
It'll take me
I haven't buy any gadgets recently. Actually, when I buy a new gadget, nice. I did watch Mandalorian Monday. When I buy a new gadget, it's a new notebook. That's what I buy.
Nice. Well, I think we're coming to the end of a conclusion here. Thanks very much for our one listener. I'm just kidding. But this is fun. I mean, I learned a lot just by talking to you about just that little bit of time. I learned a lot about metal 3D printing, and I'm hoping to do this more in the future. I
enjoy. You can call me anytime.
Yeah, thank you. Well, have a good day, everybody, and we will see you another Thursday.
Bye-bye. Thank you, Jenny.
Bye-bye.
That's it for this episode. Be sure to follow us on Facebook, Twitter, and Instagram at 3D Heals, and check out the links in the show notes. See you next time.